Hello class, this is Ms. Martins and we are finally in another unit, Unit 8, Energy. Today's objective is students would be able to analyze a heating curve to identify phases, melting point, and boiling point. So the phases, if you could recall, are solids, liquids, and gases. Remember that solids are close together in arrangement. They have a regular pattern. They're very organized. Movement of particles, they vibrate on the spot. And this is how the diagram looks for a solid, the particle diagram. Liquids are still close together, however, they're more of a random arrangement. They aren't as organized as a solid. They move around each other as seen in this diagram here. Gases are far apart. They have a random arrangement. The particles are as spread out as possible, as you can see in this diagram, and they move quickly in all directions. So what is a phase change? A phase change is from one state to another, so going from a solid to a liquid, liquid to gas, gas to solid, etc., without a change in the chemical composition. So, for example, going from a solid to a liquid, that is called solid to, let's go this way. Going from a solid to a liquid is melting. Liquid to a gas is evaporation. A gas to a solid is called deposition. And then going from a solid to a gas is sublimation. Gas to a liquid is condensation. And liquid to a solid is going to be freezing. If you do not understand these terms, I suggest that you study this diagram as much as you can. We reviewed phase changes in the beginning of the year, so you could go back to your notes on that. But this is pretty much it. Just understanding these different vocabulary words. And if I were to ask what is the term from going from a solid to a gas, you should be able to say that that is sublimation, or going from a gas to a solid is deposition. Solid to liquid is melting. So today's objective was to analyze the heating curve using the phase changes and the phases in order to understand it. But before we get into that, our question of the day is, what is the temperature of ice? And how is this going to help us understand the heating curve? So as ice is melting, the temperature throughout the whole process is going to be 0 degrees Celsius. And same goes for as a liquid is boiling, the temperature throughout the whole process is going to be 100 degrees Celsius. The boiling point of water, we're going to use water and ice as our main example for this lesson today. So the temperature remains the same. With that being said, during phase changes, temperature always remains the same. So during phase changes, temperature remains the same. This information is very important for understanding how a heating curve works. So going back to our heating curve, this is how it looks. Notice that in general, so basically before I get into that, this is the heating curve. We have different steps along the heating curve, which I'm going to explain in a few. And we have temperature and we have time on the x-axis and temperature on the y-axis. What we mean by time is heat being added. So as the temperature is increases, as heat is being added, what is happening through to these different phases, right? So notice that in general, the temperature goes up the longer the heating continues. So this is the heating curve. However, there are two horizontal flat parts on our heating curve. We have this from B to C and D to E. This is going to be where the phase changes happens. So from A to B, that's going to be our solid. So we have our ice. Now going from B to C, that's going to be our melting. So we have our ice and liquid in that B to C component. That's where the melting happens. And another term for melting or this segment could be heat of fusion. So just make sure you understand the terminology for that. C to D is going to be our liquid. Remember, we're adding heat. So the time is as you add heat, as the temperature rises, what is going to be happening to our solid? So initially it melts. In this melting phase is going to be both a solid and a liquid. And for water, we know that our melting is going to be at 0 degrees Celsius. Then we finally have our liquid and the temperature is changing. And then we finally reach a point of boiling, otherwise known as the heat of vaporization. And in this heat vaporization, we have both a liquid and a gas phase here. And then from E to F, we have our gas. So our liquid has evaporated and we have our gas. So this graph actually works looking at it backwards as well, so that we can explore all of the phase changes. So going from E to F, we have our gas, and then as our gas is changing back into the liquid, that is called condensation. So I just want you guys to look at the graph going backwards. It works either way. Condensation is also known as heat of vaporization. If we're talking about a liquid, we can also say that this is going to be the boiling point. The condensation point and the boiling point is both going to be at 100 degrees Celsius for water. So we finally reach our liquid. Our temperature is going to be decreasing if you're looking at it backwards. And then we have our freezing / heat of fusion. And then next, we are back to the solid. So going from a liquid to a solid is going to be the freezing point. So I just want you guys to understand how to look at this graph in both ways, moving forward and backwards. And another key component to understand, to note, is that different substances have different melting points and boiling points. We only looked at water, which melting point is 0 degrees Celsius and boiling point is at 100 degrees Celsius. But the shapes of their heating curves are very similar. So this heating curve here is for iron, a metal that melts at 1,538 degrees Celsius and boils at 2,861 degrees Celsius. So it's the same exact format for the heating curve. This is our solid. This is going to be where the melting happens here. So we're at a solid and liquid phase in this component. And they stated that the melting point is about 1,538 degrees. If we move over here, we can see that that could be slightly accurate. Obviously, this graph isn't very precise, but the number seems right. Then this is our liquid phase here. And then this is going to be our boiling point here. And they said that's around 2,861 degrees Celsius, which seems pretty accurate as well. Okay, so our heating point, the point of this slide here is to tell you that the heating curve is generally going to be the same shape. You're going to have the melting point here and the boiling point here. And the key thing to note is that the melting and the boiling points, the number is going to be constant. Like as you can see here, the temperature does not change during the phase change. The temperature is going to remain the same. So heating curves show how the temperature changes as a substance is being heated up. Cooling curves are the opposite. They show how the temperature changes as a substance is cooled down. Just like heating curves, cooling curves have horizontal flat parts where the state changes from gas to liquid or from liquid to solid. These are mirror images of the heating curve. So I already showed you guys the heating curve. This is the cooling curve. It's the exact same thing. It's just flipped because as time is going, we're actually cooling it. We're not adding heat, we're removing heat. So temperature is going to be decreasing. So we have our gas state here. Remember, for the heating curve, you start with your solid, but we're going to be starting with the gas for our heating curve because we're getting cooler. And then condensation occurs where our gas changes into liquid. That is also going to be called the heat of vaporization. That is also the same temperature in which boiling point occurs. Then we're going from our liquid to our solid, and there we have our freezing / heat of fusion. So we're going to go through a couple of examples of questions. I'm only going to do 3 questions. These 3 questions came straight from your practice problems, so make sure that you understand how to do them. If you don't, please revisit this video and watch it as many times as possible. You can also ask questions within the Google Classroom. So this question states, the graph shows the relationship between temperature and time as heat is added to 1 mole of a substance at a rate of 100 calories per minute. The substance is in the solid phase at time equals 0. So basically, they're just explaining what this graph is about. Time equals 0. They're saying that the substance is starting with the solid phase. We don't know what the substance is. This is our temperature, and this is time. We can see that this is a heating curve because as the time is progressing, it's getting hotter, right? The temperature is increasing. So they're asking us, what is the temperature at which the substance begins to boil? So we know that this first line here is representing the solid. This is going to be the melting point. The melting point is about 40 degrees Celsius. Then this is where it's at its liquid. This is going to be the boiling point. And remember, the melting point and the boiling point remains constant. At the melting point, we have about 80 degrees Celsius. So our answer is going to be 80 degrees Celsius. That is the answer. That is the temperature at which the substance begins to boil. And then up here, we have our gas. The next question. The temperature of a sample of a substance is increased from 20 degrees Celsius to 160 degrees Celsius as the sample absorbs heat at a constant rate of 15 kilojoules per minute at standard pressure. The graph below represents the relationship between the temperature and time as the sample is heated. So basically, this whole thing here, it just explains the entire graph. We're going from 20 degrees to 100 degrees Celsius. The sample absorbs heat at a constant rate of 15 kilojoules per minute. So they're telling us how much heat is absorbed as we increase the temperature. And the graph below just represents the relationship between the temperature and the time as the sample is heated. The question is, what is the boiling point of this sample? So we know that this first line here is the solid. This line here is going to be the melting / heat of fusion. This line here is going to be liquid. Then here we have our boiling point. Our boiling point is approximately at 120 degrees Celsius. So that is going to be our answer, 120 degrees Celsius. If you have any questions, try to watch that segment again to understand it. If not, I will be going on live sometime this week or ask the questions in the Google Classroom. Feel free to reach out with whatever way you can. So for our final question that I'm going to review, you have a bunch of questions to go over during in the Google form practice. It states the diagram shown represents the uniform heating of a substance that is a solid at time equals 0, at T equals 0. What is the freezing point of this substance? So our freezing point is going to be, so let's go through this graph, right? So we have our solid here and our liquid here. Freezing is going from a liquid to a solid. So this is our melting and our freezing point. What is the time at during this segment here from 1 to 2, right? And that links up with 12 degrees Celsius. So our answer is going to be 12 degrees Celsius. So you have to look at this heating curve in terms of phases, where the phase is happening. Remember, our solid is here, our liquid is here. What phase changes are occurring? When you go from a solid to liquid, that is melting. When you go from a liquid to a solid, that is freezing. When you go from a liquid to a gas, that is boiling. When you go from a gas to a liquid, that is condensating. So once you understand those terminologies, you should be able to answer these questions effectively. That is all for today's lesson. Please review the reading that I've put up on the Google Classroom along with this PowerPoint. Complete the Google form entitled Heating/Cooling Curve Practice. Complete the heating, cooling, exit ticket. That is what I'm actually going to be grading. So do the practice questions first. I did the first 3 for you guys. Make sure you read the directions on how to input your answers. If you have any questions, email me or write in the comments of the Google Classroom. I am always here. And always stay safe and be well. I hope you guys are doing okay. Thank you for listening to this lesson.